Hello dear viewers, a very warm welcome to our channel. It's very good to have you here. In this video, we're going to have a look at the basic components of air brake system or a pneumatic brake system and how the parts are connected and what they function for, what they're doing. Well, let's begin from part number one. Right here we have the compressor. This is an air compressor which is driven by the crankshaft. There is a pulley to be connected to the air compressor crankshaft, and it will be driven once the engine is started. So the compressor is there to convert mechanical energy received from the engine crankshaft to compressed air. Air would be admitted on the inlet, and then pressurized air will be supplied to the pneumatic brake system from the air compressor. So the air compressor is a very crucial component that produces the air pressure that is required to operate the entire pneumatic system. Then after the air compressor, supply will be directed to part number two, which is a pressure regulator. This will regulate the entire pressure inside the system. Well, there is a pressure at which this regulator is designed to operate. Once the air pressure exceeds that value, it will discharge the excess pressure. For example, once the pneumatic system has been filled by the compressor, the engine will still continue running, so the air pressure that is being pumped into the system will have to be discharged somehow, and that is done by the air pressure regulator. You might heard frequent discharge of compressed air from a pneumatic brake system. That is done by the regulator. On some vehicles, the regulator have a connection for filling a tire. For example, if you want to have an air supply from your pneumatic system, if you want to take air from the pneumatic system and somehow use that, there is a connection. Right here you see there is a connection, for example. Connecting hose to this, you can inflate a flat tire or anything that can be operated by pneumatic air, you can take from the regulator. So some regulators, they have an extra output for air supply. And some regulators have air dryer connected to them. If there is moisture coming in with the incoming air, that will be trapped inside the dryer. And on some systems, this regulator is also connected to the regenerative tanker. So this is the main duty of the regulator, however, is to regulate the entire pressure inside the pneumatic brake system. Now, after the regulator, pressurized air will be supplied to 4-circuit safety valve. This is a 4-circuit safety valve. The function of the 4-circuit safety valve is, one is to distribute air to the different circuits. As you can see, there are different lines coming out of this. There is one input and there are multiple discharge, multiple outputs. For example, going to the tankers, going to the parking brake valve, all this will be distributed by the 4-way circuit protection valve. But the main and big function of this main circuit safety valve is to prevent air leakage from damaging the entire system. If there is air leakage in one of the circuit, it will block the defective circuit and it will allow the remaining circuit to operate at lower pressure. So that is the main duty of the 4-circuit safety valve. This is why we call it a 4-way circuit protection valve, or sometimes known as the 4-circuit safety valve. It will distribute the incoming pressure, and if one of the circuit becomes defective and start leaking air, it will block that and it will let the others operate with lower pressure. Now the air supply from the regulator and compressor will pass through the 4-way circuit protection valve and it will be stored in these reservoirs. Right here you see number 6 is reservoir. This is a storage for a compressed air. So whenever you apply brake, readily available air will be supplied from the reservoir. So there is no waiting time. Already compressed air is made abundantly available in this tank, and then from those tanks you can use an already supplied high pressure to operate the brake valve, for example. The main enemy of a pneumatic system is moisture trapped inside the system. As you can see, there are drain valves installed on every tank. Some of the drain valves are automatic, some of them are manual. So the drain valve is there to open a passage and discharge any moisture that is trapped on the lower part of the tankers. So air reservoirs, when they have moisture trapped, the moisture will sink to the lower side, it will sip, it will condensate right here, and once this valve is opened every morning, for example, that will discharge the moisture that is trapped in here. Always make sure that your pneumatic system is moisture free. Otherwise, that will cause some problem on the parts. It will cause corrosion and rust to develop internally. That is why it is very crucial to discharge the reservoirs every morning. Before you start setting off to motion jet, discharge it and let the compressor fill the tanker again. That way you can have a moisture-free air supply to the entire pneumatic system. Now, on this particular vehicle, we have two types of brakes to be operated. One is the service brake, right? Number 3, you see here, number 3 is the service brake valve. This is a foot-operated brake valve. The foot-operated brake valve has two connections, one for front and one for rear, and that is a split type. If there is a problem with the front, you can park with the rear. If there is a problem with the rear brake, you can have your vehicle slowing down with the front brake. That is why we have a split type connection at the service brake valve. Now the idea is when you depress this pedal, this is a foot operated brake pedal, when you operate this pedal, the service brake valve will supply compressed air. One compressed air will be directed to the load sensing valve, and the load sensing valve will direct compressed air to the rear brake chambers, and another circuit will supply compressed air to the front brake chambers. The front brake chambers, designated by number 9, they are the ones that convert the pneumatic pressure to a mechanical force that will engage brake. This engage brake by applying pressure on the brake shoes of the front wheel. Similarly, air that is directed to the rear wheel, which is supplied to the rear brake chamber, will also generate mechanical force to operate the rear wheel brake. So by simply depressing the service brake valve, you can operate both the front wheel and the rear wheel as well. And the amount of air that is going to be supplied to the front brake chamber and to the rear brake chamber depends on how much the depression is. When you depress it more air will be allowed to pass to the brake chambers. When only lightly it is depressed, only a small amount of pressure is to be supplied to the brake chamber. So the braking volume or the braking intensity is dependent on how well this is pressed. When you want sudden braking and when you want large braking, you have to depress it much, allowing high pressure to be passed to the brake chambers so that brake can be applied strongly. But when you lightly tap on the brake service pedal, only small amount of pressure will be supplied to the brake chambers, and that will slow down the vehicle only. The other circuit that is using a pneumatic circuit is the parking brake. Right here you see the parking brake valve. The parking brake valve is there to operate the parking brake. Now, parking brake valves, as you can see, the line coming from the parking brake valve will be connected to the rear chamber. This is a combination chamber. We have two sections in here. There is a spring-loaded parking brake section on the back side, and there is a diaphragm-operated service brake chamber on the other side. All are exerting force on this push rod in order to engage or disengage brake. For example, when service brake is applied, air coming from the service brake valve and the load sensing valve will be supplied here, and it will act on the diaphragm of the combination chamber so that it will push this push rod, so brake will be applied. But when it comes to parking brake is actually applied by a very tough compressed spring in here. If the spring is not compressed and if the spring is relaxed, the spring will exert force on the push rod, and that will engage the rear wheel brake. If, however, air is supplied to this chamber and compress that brake to the right side, that will prevent force exertion on the push rod, and brake will be released. So the parking brake valve will supply air in order to disengage the parking brake, and it will discharge this air that is compressing the spring in order to apply parking brake. It is opposite to the other brakes. Parking brakes on this type of trucks, they operate by a spring force. The spring force is selected because it is an emergency. If there is some problem with the entire pneumatic system, that spring will apply brake and the vehicle will be kept stationary. Now, in order to disengage that, you have to introduce compressed pressure so that the spring can be compressed back away from the push rod. That is done by the parking brake valve. When you want to disengage parking brake, all you have to do is apply pressure into this chamber, compressing the spring and preventing it from applying pressure on the push rod. When you want to apply parking brake, however, the parking brake valve will connect this line to the atmosphere. It will vent this line to the atmosphere, venting the pressure that is trapped. The pressure that was compressing the springs will be discharged out when parking is applied. That way, a mechanically strong spring force will exert parking brake. If you want to tow your vehicle and manually disengage the parking brake, there is a very tough long screw on the back of the combination chamber. Unscrewing this will manually compress the spring, preventing it from exerting force on the push rod. So if the pneumatic system is not functioning and you want to tow your vehicle, all you have to do is use this bolt in order to disengage the parking brake application. So this is how the parking brake is operated. And one final component we have right here is number 8, the load sensing valve. The load sensing valve is there to limit and meter the amount of air that is being supplied to the rear wheel depending on the load of the vehicle. If the vehicle is loaded, large amount of air has to be supplied to the brake chamber to apply brake. But if the vehicle is lightly loaded, or if it is not loaded, however, only small amount of force has to be exerted to the rear wheel in order to prevent wheel lockup. If the amount of air that is supplied to the rear chamber is always the same irrespective of the load, when load varies, the rear wheel might lock up. That is prevented by the use of the load sensing valve. So when there is large amount of load on the vehicle, the load sensing valve will allow massive amount of air to pass to the rear chamber. But if the vehicle is lightly loaded, it will allow smaller volume of air to pass to the rear wheel chamber. So this is how the pneumatic brake system operates. This is a very simple demonstration showing you how the entire component is connected and how it is designed and how it is operating. Well, dear viewers, that is all we have for you regarding the basic components of a pneumatic brake system with individual units represented here and pneumatic components shown how they are connected. If you find this video helpful and if you like what has been presented, please smash the like button. If you are new to this channel, do consider subscribing, turn on notifications so that you will be the first to get notified whenever we come up with another video. Until then, stay safe.